Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR November 2024, paper 5, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1. Work out 1 5/6 minus 2/3 divided by 3/4. Okay, so we've got a whole lot of fractions going on here. Also got a bit of BIDMAS. So BIDMAS says we need to do division before we do subtraction. So we're going to do this little bit first, and then whatever we get then we're going to take away from 1 5/6. But in the meantime I'm just going to change this one at the front here into an improper fraction because I find those easier to add. So 1 times 6 is 6 plus 5 is 11, isn't it? So that is 11/6. Then we've got 11/6 minus, now when we're doing fraction division we use keep, change, flip, don't we? So we're going to keep the first fraction the same, going to change the divide into a times, and we're going to flip the second fraction over. So it becomes 2/3 times 4/3. Okay? Right, is there anything top and bottom I can cancel? Nope, so I'm just going to have to go ahead and multiply. So that's going to give me 11/6 minus 2 times 4, that is 8, over 3 times 3, that is 9. Okay? So now that the division's out of the way, let's move on to do the subtraction. When you're adding and subtracting fractions, you need the same denominator. I've got different ones here, 6 and 9, but they both go into 18, don't they? If I times top and bottom of this one by 3, and I times top and bottom of this one by 2, I'm going to get some equivalent fractions over 18. So 11 3s are 33, 6 3s are 18, minus 8 2s are 16 over 9 2s, which is 18. So I've got 33 18ths minus 16 18ths. Now the denominators are the same. I can just go ahead and subtract the numerators. So what's that? 17 18ths. That's my final answer then. 17 over 18. Question 2. Work out the size of an exterior angle of a regular hexagon. Okay, so regular means they're all the same size and angles, aren't they? So we've got like a standard hexagon, poorly drawn by me, but you get the idea. And if it's regular, that means all the sides are the same, same, and all the angles are the same. Okay, but these are the interior angles, aren't they? We don't want the interior angles, we want the exterior angles. So to find an exterior angle, it's all those angles. If you extend the lines out like this, they're the exterior angles. So it's these ones. Okay, then find those. We just have to divide the 360 by the number of sides, don't they? Because if you imagine walking around that shape, all of those little angles would add up to 360. So one exterior angle would be 360 divided by the number of sides, which in this case is 6. So that's going to give you 6s into 360. Goes 60 times, doesn't it? So that's 60 degrees. Okay, so that's my answer, 60 degrees for that one. Use your answer to part A to write down the sides of an interior angle of a regular hexagon. Well, these angles lie in a straight line, don't they? So if I know that the yellow one is 60, then the other one is going to be 120, then it's going to be 180 minus the 60, and that's going to give me 120 degrees. Question 3. The graph shows the time in minutes taken by some pupils to travel to school on Tuesday. So we've got less than 10, 10 to 30, more than 30, and a frequency there. Find the percentage of these pupils that took more than 30 minutes to travel to school. Okay, so we need to know, to work out the percentage, we need to know how many people there were altogether, and we need to know how many were more than 30. Now this is a very poorly drawn thing. I can't decide if it's a bar chart or a histogram. It's got frequency up the side, so which makes you think it's a bar chart, but bar charts are normally for discrete data and then normally have gaps in between, so I don't know what this thing is. It's just a weird thing. Okay, so how many are there all together? Well, I've got 60 in the first bar. That has to just be frequency, doesn't it? I've got 150 in the middle bar, and I've got 90 in the end bar. So altogether, 150, 60, and 90. What does that add up to? 20. That's 300 students altogether. So there are 300 students, of which 90 took more than 30 minutes. So what we want to do is write 90 over 300 as a percentage. Now, a percentage just as a fraction over 100, so if I divide both of those numbers by 3, that's what I'll get, isn't it? So 90 divided by 3 is 30, 300 divided by 3 is 100, so that's 30 over 100, and that just means it's 30% then, doesn't it? Part B says, on Tuesday, the number of pupils taking the 10 to 30 minutes to travel to school was 25% less than Monday. Find the number of pupils taking the 10 to 30 minutes to travel to school on Monday. Right, so we know there are 150 students who went to school on Tuesday taking 10 to 30 minutes. And then if that's 25% less than Monday, that must be 75% of Monday's score then, mustn't it? Because if we had Monday's score and then reduced it by 25% and we've got Tuesday's score, then that is 75% of Monday's score. Now, if I divide that by 3, I should be able to find out how much 25% is. So 25% then is 50. So then if I want to have 100% of Monday's score, then I'm just going to add these two together, then, aren't I? So 75% and 25% is going to give me 100%. So 150 plus 50 is 200. So there must have been 200 students coming to school on Monday, so that when we reduced it by 25% on Tuesday, we're going to have 150. That kind of makes sense, doesn't it? Question 4. An electrician charges £30 per visit plus £22 per hour. Write an expression for the cost in pounds charged by the electrician for one visit lasting n hours. Okay. So the cost then is going to be the £30 call-out charge plus the number of hours times by 22 then, isn't it? So it's equal to 22n plus 30 then. Question 5. Annika has a shelf 79.6 centimetres long. She has many books, each of width 3.4 centimetres. Annika puts 2 paperweights, each of width 5 centimetres, and the maximum possible number of books on the shelf. Work out the amount of space on the shelf that is left over. You must show your working. Okay, so we've got these 2 paperweights, each of 5, so if I times them by 2, that means they're taking up 10 centimetres of the shelf then. So what's the remaining shelf? That's going to be 79.6 minus the two paperweights, which leaves me with 69.6. Okay, then we now need to see how many of these 3.4 centimeter books we can fit in that remaining shelf. So that's a division, isn't it? So the number of books is going to be 69.6 divided by the width of one book, which is 3.4. I think I'm going to do that as a division. Okay, I'm just going to make the maths a little bit easier by myself by multiplying both those numbers through by 10. So that's the same thing as 696 divided by 34. Okay, so I'm going to do a bit of long division. 34s into 696. 34 into 6 doesn't go, so 34 into 69. How many times does that go in? Well, 34 times table is 34, 68, 102. So you can see it goes in twice there, doesn't it? So it goes in twice. 2 lots of 34 is 68, and then subtract. That's going to be 16. 34 is into 16 goes 0 time. Now obviously there's going to be a bit of a remainder there, but I think it's a bit clearer, I think, if I work out how wide those 20 books are. So width of the books, that's going to be 20 lots of 3.4 then, which is 68 centimeters. Remember I had 69.6, so shelf remaining then is going to be 69.6 minus the 68, and that comes out to be 1.6 centimeters. Question 6. Jack has 10 cards numbered 11 to 20. He picks a card at random. Jack says, in these 10 cards there are 2 multiples of 5 and 5 even numbers. Therefore, the probability that I pick a card that is a multiple of 5 or an even number is 2/10 plus 5/10 equals 7/10. Describe the error in Jack's method and give the correct answer. Okay, well, I guess he's thinking there are 2 multiples of 5. There are 15 and 20 as the multiples. And the even numbers are going to be 12, 14, 16, 18, 20. So his 2 plus his 5 makes 7 out of 10. But you'll notice you've got a 20 and a 20 here. So he's counted that 20 twice. Okay. Now you can only add probabilities together if they are mutually exclusive like this, and they're not, because they both contain a 20 and therefore they are not mutually exclusive. So I'm going to write down multiples of 5 and even numbers are not mutually exclusive, as 20 is in both. Okay, so the correct answer is, well, you've double counted the 20s, isn't it? So if I remove one, then you can see I've got actually 6 different outcomes that are one or the other. So it should be 6 out of 10, okay, and not 7 out of 10. If you're interested, the proper formula, the full formula for working out the probability of event A or the event B is equal to the probability of A plus the probability of B, like he's done. But you then need to take away the probability of A and B, the intersection of those two groups. And that's what we're doing here. But the fact that there is one number in both means I have to take 1 out of 10 away from 7 out of 10 in order to get 6 out of 10. Question 7. Felix makes craft figures at a constant rate. He can make 5 craft figures in 40 minutes. Find the number of craft figures that Felix can make in 4 hours. Okay. Well, if you can make 5 craft figures in 40 minutes, then time for one figure would be 40 minutes divided by 5, assuming he works at a constant rate. So he's just, you know, churning out figures one after the other. And 40 divided by 5 is 8. So it takes him 8 minutes per figure. So then if I want to work out how many he can do in 4 hours, I'm going to have to divide 8 minutes into 4 hours. But units, I need to make sure 4 hours is in minutes first. So 4 hours equals 4 lots of 60. It's 100. No, 240 minutes, isn't it? 240. Double and double again, times it by 4. So 240 minutes. So then what I want to do then is I want to divide my 8 minutes into my 240 minutes to see how many figures he can make altogether. So 8 into 240. 8 into 2 don't go. 8 into 24 go 3 times, remainder 0. 8 into 0 goes 0 times. It goes, he makes 30 figures. 30. Right, so then Darcy makes craft figures 10% quicker than Felix. Work out how long Darcy takes to make 15 craft figures. I don't really like the English of this. It's 10% quicker. What does that mean? I guess what it means is that Darcy's time is a reduction in 10%. So we have to take 10% off the time it would take Felix to make it, and then that's how much time Darcy would make them in. So if Felix can make 30 figures in 4 hours, then presumably Felix can make them in 2 hours, which is because it's half as much, isn't it? So 15s into 30 go twice, isn't it? So it's half the time. And 2 hours is 120 minutes, okay? So then Darcy is going to do that in 10% less time. If 100% is 120, then 10% would be 12 then, isn't it? So then to get 90%, I would need to subtract those from each other. So 120 take away 12, that's 108 minutes. So that's how long it takes Darcy to make those 15 figures. Question 8. Here is a question and an incorrect answer. Question. Expand the brackets and simplify fully. 3 lots of A plus 2B plus A. And he's written down the answer A4 plus 6 times B. Explain why the answer is not correct. Okay, well, it's kind of correct. It's just the way he's written it down is not quite right, is it? If I multiply this out, the brackets out, I'm going to get 3 lots of A, which is 3A, plus 3 lots of 2B, which is 6B, which is 6B. Plus I've got this extra A on the end. So collecting like terms, the 3A and the A is going to give me 6 4A, and then I've got that 6B on the end, haven't I? Okay, just the same as before. Right, so it should be 4A plus 6B. Now, if you compare that with what he's written down, he's written A4, so he's got these the wrong way around. And rather than writing 6B, he's written 6 times B, so he's left the multiplication sign in. So that's the two things things he's done wrong. So it's not correct because the number and letter in the first term are the wrong way around. And he's left the multiplication sign in the second term. Okay, so that's what he's done wrong. He's made 2 mistakes. So it's a 2-mark question. They're looking for both mistakes for the 2 marks, I think. So you need to mention both of them, I would say. Question 9, I have got a linear equation. Solve 3x plus 12 equals 9 minus 7x. Notice I've got unknowns on both sides here. So the first thing I'm going to do is going to get rid of that minus 7x on the right. And I'm going to do that by adding 7x to both sides. Okay, they'll cancel, leaving me with 9 on the right. And on the left, I'm going to get 3x plus 7x, which is 10x, plus that 12 that was already there. Okay. So next step is get rid of the 12, take 12 away from both sides. That's going to give me 10x equals 9 take away 12, that's minus 3. Don't be afeard of the negative numbers. And then dividing through by 10, they're going to cancel, leaving me with x. And then my final answer then is x equals minus 3 over 10. So again, don't be afeard of the fractions. I'm just going to leave it as a fraction, actually. Some people feel like they have to convert everything to decimals. I do not. Yeah, fractions are your friends. Get used to them. Question 10. A straight line is equation y equals 4x plus 9. Write down the gradient of the line. Well, equations for straight lines are always the form y equals mx plus c, where m is the gradient, it's the coefficient of x, and the coefficient of x here is that 4. So here my gradient m is equal to 4. Casey says the graph of y equals 4x plus 9 passes through the point 3, 23. Is Casey correct? Show how you decide. Okay, well, the equation of the line is the rule that links your y coordinates to your x coordinates. So if the point 3, 23 lies on the line, then I should get 23 when I sub in 3. So if I've got y is equal to 4 lots of 3 plus 9, if that comes out to be 23, then it must lie on the line. If it comes out to a different number, it doesn't. So let's find out. So what is 4 times 3? 4 times 3 is 12 plus 9. That's equal to 21. That's not right. Okay, so we got 21 and it's meant to be 23. So is Casey correct? No, because y is equal to 21 when x is equal to 3 and not 23. Therefore, 3, 23 is not on the line. Question 11. A bag only contains green, red, blue and yellow discs. Orla carries out an experiment. She picks one disc from the bag, records its colour and then returns the disc to the bag. When she has finished the experiment, Orla works out the relative frequency of each colour. Some of her results are shown in the table. So we've got the relative frequency of green and red given. So the relative frequency of the yellow discs was 3 times the relative frequency of the blue discs. In total, there was 2,000 discs in the bag. Use this information to find an estimate of the total number of green and yellow discs there are in the bag. You must show your work in. Okay. So we've been given a ratio here, haven't we? So the frequency of the yellow discs to the blue discs was in the ratio of 3 to 1, wasn't it? So it was 3 times as many yellow discs, or the relative frequency was 3 times higher than the blue discs. So the ratio of yellow to blue is going to be 3 to 1 then, isn't it? So we're going to have 3 yellow discs for every 1 blue disc, presumably. Okay. And what relative frequency do we have to share between the yellow and blue discs? Well, if we add up the two I've got, 0.35 plus 0.25, that comes to what? 0.6. So I've got 0.4 left, haven't I? So I need to share 0.4 between these two values. Okay, so yellow plus blue is 3 parts and 1 part, which is 3 plus 1 is 4 parts. We have to divide by a ratio here, don't we? So then I need to do 0.4 divided by 4, which is 0.1. That means that each one of my shares is a value of 0.1. So that means then the ratio is going to be 0.3 to 0.1 then, isn't it? Okay, so that means the relative frequency of yellow is going to be 0.3 and the relative frequency of blue is going to be 0.1. So if in total there are 2,000 discs in the bag, I need to work out the total number of green and yellow discs. So the number of green discs is going to be 2,000 times by 0.35. What's that then? So 1,000 times 0.35 would be 350. So 2,000 is going to be 700, isn't it? So it's going to be 700 green discs, and then yellow discs. Just worked out the relative frequency was 0.3. So it's going to be 2,000 times 0.3. That's going to be another 600 discs. So then altogether then, the total number of green and yellow discs is going to be 700 plus 600, which is 1,300. Part B says explain why your estimate may not be reliable. And then that comes back to the methodology that did. We don't know how many trials all are made in order to do these probabilities, as they're like multiples of 5, and maybe not that many. We don't know how many trials all are made. If the number was low, then the estimates may be poor. Question 12. A housing estate is built on a triangular piece of land. There are 3,951 people living on the estate. Work out an estimate of the population density of the estate in people per square kilometre. Okay, so the formula for population density, that's just equal to population divided by area. Okay, it's one of the compound units that you need to know for the exam. So population density is population over area. So we know the population. Do we know the area? Well, we've got the two parts of the triangle. We've got the base and the height. And we've also got the word estimate here. So, I mean, I was looking at 5.03 and thinking, do I need to multiply that by 1.96? I guess I don't, because it's an estimate question. So I'm going to say that rounding each one of these off, I'm going to say, well, that must be 2 kilometers to the nearest kilometer, and that must be 5 kilometers to the nearest kilometer, and this must be 4,000 people to the nearest 1,000 people, or one significant figure. So rounding them each one off to one sig fig, so then I can work out the area much easier. So the area of a triangle is half times base times height, which in this case is a half times my rounded off value of 5 times my rounded off value of 2. They cancel, leaving me with an area of 5, roughly. And so then the population density is going to be my 4,000 people divided by my area of 5. Okay, so that's going to be in square kilometers there, isn't it? So 4,000 divided by 5. So if I double it and take a 0 off, I'm going to get 800, aren't I? So I've got roughly 800 people per square kilometre. Question 13. Write 4/11ths as a recurring decimal. God, we've done lots of division in this paper so far. Lots of long division. We're going to have to do some more now. 4 divided by 11. That means 11's into 4 then, isn't it? So I'm going to have to add some extra zeros in, I guess, so I can see what the pattern is going on here. So 11's into 4 don't go, that goes 0 times. 11's into, so carry a 4 over. 11's into 40, that goes 3 times. Remainder what? So 3 11's are 33. So the remainder is 7. And then we've got 11's into 70. That goes 6 times, because 6 11's is 66. So the remainder is 4. And we're kind of back where we started then, aren't we? Because we know 11's going to 43 times remainder 7. 3 times remainder 7. And then the process carries on again. So I'm going to get another 6 then, aren't I, at the end of this one. and so on. And after that, we know it's going to repeat. So it's going to go 3, 6, 3, 6, 3, 6. So what is it as a recurring decimal? It's 0.36 with a dot on the 3 and a dot on the 6, because it's kind of repeating every two blocks like that, isn't it? So it's 3, 6, 3, 6, 3, 6. So we have to put a dot on the first number and the last number of the repeating part of the pattern. Question 14. The expected value of a painting, P, is given by the formula P is 2,500 times 1.2 to the power of n, where n is the number of years after it was bought and 0 is less than or equal to n, which is less than or equal to 4. Okay, so n lies somewhere between 0 and 4. Write down the value of the painting when it was bought. Well, when it was bought, n was 0, isn't it? So n is 0 at the time it was bought. So then we've got P equals 2,500 to the power of 1.2 to the power of 0. And anything to the power of 0 is 1, and 1 times anything is itself. So that means that 2,500 is the starting value of the painting, isn't it? And then write down the annual percentage increase in the expected value of the painting. So this part here, as a multiplier, is of 1.2. As a percentage, 1.2 is 120%. Okay, so that means it's an increase of 20% each year, because we're getting 120% from 100%. So it must be going up 20% each year. C says the table shows the expected value of the painting n years after it was bought. Below, draw a suitable graph to show the expected values of the painting n years after it's bought, for where n lies between 0 and 4. So don't forget, we had already worked out the price for n equals 0. That was 2,500. So I'm going to put that point on first. 0 goes with 2,500. Then 1 goes with 3,000. These lines are very small. Not like those. And then it goes to 3,600. 3,600. What's the scale here? So I've got like 3,500 and 3,750 and 5 little blobs in between. So 5 blobs is 250, so 1 blob is going to be 50, isn't it? So if I want 3,600, there's going to be 2 little squares above 3,500. These lines are making my eyes go wonky. So 2 little squares. And then 4,320. I'm just going to plot that at 4,300, and like that little extra 20 is going to make a lot of difference at this scale. So 4,300 is going to be one little squidge above 4,250. And similarly, 5,184, I'm just going to plot that at 5,200, which is about one little square below 5,250. So I'm going to plot it there. Again, you know, on this scale, the extra bit is going to make a lot of difference. Okay, so I've got my points. Now you might be thinking that's a straight line, but it's actually going to be a gentle curve, isn't it? It's an exponential curve, really. So joining those up with a straight line. So you need to draw a kind of freehand curve through this, not use a ruler. Like that. It should look something like that. Part D says an art collector correctly works out that 2,500 times 1.2 to the power of 10 is 15,479. They say the expected value of the painting 10 years after it was bought was 15,479. What assumption has the art collector made? Well, he's assuming then that the painting increases at the same rate as it did in the first 4 years. That the painting value will continue to increase at the same 20% rate as the first 4 years. Question 15. A diagram shows a rectangle OPQR and a circle centre O which passes through Q. OR is 6 centimetres, RQ is 8 centimeters. Find the circumference of the circle, give your answer in terms of R. I think that should say pi, in terms of pi. In order to find the circumference of a circle, we've got two formulas. We've got C equals pi d, cherry pie delicious, but 1 diameter equals 2 radii, isn't it? So the alternative way of writing this down is C is equal to 2 pi r. Okay, I'm going to use that in this case because I want to find this radius. The radius is the distance from O to Q, if you think about it. That's our value of R. And R is the diagonal of that rectangle. So I can work out the length of R using Pythagoras theorem. I should know that R squared, the length of a longer side of a right angle triangle, is the square of the other two added together. So 8 squared plus 6 squared. Now I already know the answer to this. It's 10 because I know my Pythagorean triples, which are like 3, 4, 5, and any multiples of 3, 4, 5. So 6, 8, 10 is the next one. So I can see I've got 8 and 6, so I know then that R is going to be 10. But if you didn't know that, I guess you'd have to work it out. That'd be 64 plus 36, which is 100. So R is going to be a root of 100, which is 10, like I said a moment ago. Okay, but knowing your Pythagorean triples, so 3, 4, 5 is the one that comes up the most often, but also sometimes 5, 12, 13 comes up on the non-calculated paper. So good to remember those, helpful in these sorts of scenarios. So anyway, we know then that radius is 10, so then the circumference of this thing is going to be 2 times pi times 10, which is 20 pi, which is 20 pi. In terms of pi, it's 20 pi. Part B says AOB is a sector of a circle, centre O and radius 8. AOB is x. The arc AB has length 2 pi centimetres. So that should be 2 pi. Find the area of the sector. Give your answer in terms of pi. Okay, my computer doesn't seem to like pi today. So yeah, the arc is AB is 2 pi. Okay, so what is the angle at the centre? Well, we know the circumference of a circle is normally 2 pi r. We said it earlier. But if you've got a sector is a fraction of a circle. So an arc length is the fraction of the circumference. So it's going to be whatever the fraction is times 2 pi r, isn't it? Okay. What fraction we got here? Well, we've got the angle x at the centre, and we've got the angle 360 degrees in a full circle. So we've got x 360ths of 2 pi r. Okay, that's going to be my arc length. Now, it tells me the arc length is 2 pi. It doesn't tell me x, that's what I need to work out. And I know that r is given. R is given as 8. Okay. So what's that then? So, well, I'm just going to cancel that with that first off. So 1 is equal to x over 360 times 8. In other words, 1 equals 8x over 360. So that means that 8x is equal to 360. Then cross multiplying, or multiplying both sides by 360, they'll cancel. And then dividing both sides by 8, 8's into 360. How many times does 8 go into 360? It goes in 45 times, isn't it? So x is going to be 45 degrees then. Okay, so we're not quite done. That's the angle. Now we've got the angle, we then need to work out the area. So the area is going to be, well, normally for a circle, it's pi r squared, isn't it? Okay, but we have got not a full circle. We've got 45 360ths of a circle. So what's that then? Need a bit more space, I think. So 45 over 360 times pi times what was the radius? It was 8, wasn't it? 8 squared. So that's equal to 45 over 360 times pi times 64. So we know that 360 divided by 8 is 45, because we just found that a minute ago, isn't it? So if I divide 360 by 8, I get 45. If I divide that by 8, I'm going to get 8. So just dividing top and bottom by 8, aren't I? And then I can cancel that 45 into the 45, and it just leaves me then with 8 pi. So my answer then is 8 pi. 8 pi. Alternatively, you could have multiplied all that and divided that. That would be horrible. So just looking for common factors to cancel is the way to go on these. Okay, so I get 8 pi. Question 16. In the diagram below, the shaded region is a parallelogram. The parallelogram can be identified by 4 inequalities. 2 of the inequalities are y is greater than or equal to 6 and y is greater than or equal to x. Write down the other 2 inequalities that identify the parallelogram. Okay, so let's just work out which ones they've been given us first. Y is greater than or equal to x. Well, the line y is equal to x is this one, and you can see that we want the area above that line, which is y is greater than or equal to 6. Can be equal because it's a solid line. If it's a dotted line, it needs to be greater than or less than, but it can be greater than or equal to for this one. And the other line we've got is y is equal to, or is greater than or equal to x. Y equals x is this diagonal line coming up here, isn't it? So that's the line y is equal to x there. Okay. So what do we need to do? We need to define what this line is. Well, that should be quite easy. This one, this is the line y is equal to 9, and we want the bit underneath it. So we want y is less than 9. Now it has to be strictly less than because that's a dotted line. So that's our first one. Now we just need to know the other line over here. Okay, so we know the gradient of this line. We know the gradient because it's the same as y is equal to x. So the gradient is 1. So m is going to be equal to 1 because it's the same as the gradient of the green line, which is y is equal to 1x. So we know it's of form y equals x plus c, where c is the intercept. But you can see our value of c here is 4. So that value there is going to be 4. So it's y equals x plus 4. So this is the line y is equal to x plus 4. And we want the values, well, pretty much underneath that line, isn't it? Okay. We want the y values to be less than the line. We want it to be underneath the line. So it's going to be y is less than or equal to, because it's a solid line, x plus 4. Part B says work out the area of the parallelogram. You must show your working. Well, area of a parallelogram is just base times height, isn't it? So what is the base? What is the height here? So the base is going to be the distance between this point and this point. Okay, so I know this point here has got to be the point 6, 6, isn't it? Because I know the y coordinate is 6, so the x coordinate must also be 6 because it's the line y is equal to x. What about the other line? That is going to be, it's going to be 2, 6, I think so. So we want when y is equal to 6, because it's on the yellow line, what is the value of x here? So I know that y equals x plus 4, so 6 equals x plus 4. So that means that x must be equal to 2. So that point there must be the point 2, 6. Okay, there. So then the distance between those 2 points is going to be the difference between the x coordinate there, 6, and the x coordinate there, 2. So the base of this line is going to be 4 units, isn't it? So the base is going to be 4. So we just need to know the height now. Well, the height is this distance. We've got y is equal to 9 and y is equal to 6. So 9 take away 6 is 3. So the height then is going to be 3. So the base is 4, the height is 3. So then the area is going to be 12 square units. Question 17. A farmer grows pumpkins. The farmer records the mass m kilograms of 80 of their pumpkins. The table shows the results. So we need to work out the cumulative frequency. So we can do that by adding the previous numbers together, can't we? So if you think about this one here, 32, that is the sum of 10 and 22. So the next one along, I'm going to add 28 on as well. That's going to take me up to 60. Then adding 14 takes me to 74. And then adding the 6 should give me 80. So your last value should be the same as the total things there are altogether. So that's a good little check as you're going through. Okay, so they're my values that I need to draw. And then next we need to draw the cumulative frequency graph to represent these results. Okay, so we've always got a bonus point to plot at 0 and then the lower bound of the first group, which was 0. So I've got a point there at 0, 0. But after that, it is the upper bound versus the cumulative frequency. So 5 goes with 10. They've already given us the upper bound for this one, so don't have to think about it too much, just have to plot the points. So 5 goes to 10, 1, 2, 3, 4, 5 goes there. 32 goes with 10, so I've got 10 divisions between 20 and 30, so each one of those little squares is going to have to be 2 in this case. So 32, what's that? That's 4 little squares down from 40. 1, 2, 3, 4. It's going to be there. 15 goes with 60. That's a bit easier to plot. And then 20 goes with 74. So I'm going to come down 3 little squares from 80. And then this tops out at 25 and 80. So, and it's the last little point in the corner. Now these tend to have a kind of an S-shaped curve. So they start off flat. They kind of then accelerate up through those points. And you can actually draw these as with a ruler as well, the data ones. And they kind of top off the same way, so they kind of have like a 0 gradient at the top again. Yeah, so you can use a ruler for data graphs, or you can put a curve in, doesn't really matter. I'm kind of used to doing them as curves. I think curves look better, but it's easier to draw it with a ruler. Then finally, the farmer picks a pumpkin at random. Find the estimate of the probability the pumpkin has a mass greater than 18 kilograms. Now to do that, I need to find 18 on my scale. So I've got, what's that, 10 divisions between 15 and 20. So I'm going to have to go 6 little squares up from 15 then to get to 18. So 1, 2, so 18 is going to be there. So I need to read up to the graph. And then when I hit the curve, I'm going to turn left. Now on my graph, that's coming out as 60, what was that, 68? It's coming out as 68 on my graph. Okay, now yours might be slightly different if you drew your curve slightly differently, but mine comes out to be 68. Now, that tells me that there were 68 pumpkins that had a mass of 18 or fewer. There are 68 are going to be fewer than 18. Okay, so this range. But we want greater than 18. So we actually want this little bit up here above the 68. So how many people is that then? That's 80, the total, minus 68. So how many pumpkins? That's 12 pumpkins. So 12 pumpkins roughly have a weight greater than 18. So probability of picking a heavy pumpkin is going to be the 12 heavy pumpkins divided by 80, which is the total number of pumpkins. So it's 12 80ths, which you could cancel down, but I'm not going to bother. Question 18. Solve x squared minus 5 over x minus 4 equals 4x. Nice little bit of algebra. Okay. First thing I'm going to do is I'm going to cross multiply the denominator of this fraction. I'm going to multiply both sides by x minus 4, and the result will be that it kind of moves up there, and I'll get x squared minus 5 is equal to 4x lots of x minus 4, like that. Okay, so then multiplying out the brackets, 4x times x and 4x times minus 4 is going to give me 4x squared minus 16x is equal to x squared minus 5. Okay, so I'm going to collect all the x's to one side. Now I've got more x's on the right than on the left, so I'm going to collect on the right side. So I'll keep that lead term positive. So moving this x squared over the equal side, change signs, I'm going to be taking x squared away. So that's going to be 3x squared. And similarly, if I want to move the minus 5 over the equal sign, it's going to become positive. So I'm going to get 3x squared minus 16x plus 5. And that is all equal to 0. Okay, so going good. Now we just need to hopefully factorize this to find out what it's all equal to then. So can I factorize this into two brackets? Well, if I can, my lead coefficient of 3x would suggest that I've got a 3x and an x here. So when I multiply them together, I'm going to get my 3x squared. Next, let's have a look at the signs. I've got a minus and a plus. So if it's a positive number on the end but a negative number in the middle, that means I must have two negatives. So I'm going to get a minus and a minus. Okay. And then finally, number on the end. So my number on the end here is 5. Now, factor pairs of 5, not too many factor pairs of 5. 5 only has factor pairs 1 and 5 because it's prime, isn't it? So that means one of them must be 5 and one of them must be 1 in the bracket. Now, it doesn't matter which way I put round because the one I put in the second position is going to be multiplied by the 3x at the beginning. Now, I'm aiming for minus 16x, so I think I'm going to put the big number at the end, minus 5, so that when that gets multiplied by the 3x, it gives me minus 15x. And then the 1 is going to go here, so that when I multiply by the x, I'm going to get 1x, and 15x and 1x is going to give me the 16x in the middle. Okay? So I've got 3x minus 1, x minus 5, and then that is equal then to 0, because it was before. So if I've got two things multiplied together and that gives me 0, it must be that one thing was 0 or the other thing was 0. That's the only way you can get 0 is if you multiply two things and one of them is 0. So if I've got 3x minus 1 is equal to 0, moving the 1 to the other side, I'm going to get 3x as 1, and then dividing through by 3, I'm going to get x as a third, and then, or I'm going to get x minus 5 is 0, so x is equal to 5, then, isn't it? So they're my two solutions, 1/3 and 5. Question 19. A, B, C, and D are points on the circumference of a circle centre O. BD is a diameter of the circle. EBF is a tangent to the circle. Give a reason why BAD, angle BAD, is equal to 90 degrees. Well, BAD is an angle subtended off the diameter, isn't it? BD is the diameter. And we're subtending this angle off of it. So we've got the circle theorem. The angle in the semicircle is 90 degrees, so that one over there must be 90 degrees. Okay? The reason, so give a reason why angle BAD is 90. I can say that BD is the diameter. So BAD is the angle in a semicircle, which makes it 90 degrees. Okay. Write down one other angle that is 90. Give your reason for your answer. Well, which other angle is going to be 90? Okay, well that's fairly easy enough because EB is a tangent, and I know that OB is a radius because it goes from the center to the edge. It must be a radius, and it's joined at the point of contact at B. So that means that this angle here must be 90 degrees because there's always a right angle between a tangent and a radius drawn at the point of contact. So write down one other angle that's 90 degrees. It's angle EBO. Okay, EBO or EBD would be the same as well, because the angle between a tangent and a radius drawn at the point of contact is a right angle. Okay, and then write down the value of CAD. Where's CAD? CAD is this angle. What's that angle there then? Well, CAD is subtended from the arc CD. Can you see? Let's get rid of the green we used earlier. So CAD is subtended from the arc CD, but also this angle here, DBC, is also subtended from that same arc. So that means that this angle here, the 36 degrees, must be equal to this one over here. Okay, because they're subtended from the same arc. So write down the value of CAD, must be 35. And write down the value of angle EBA. EBA, where's E? Can't even see E. E? Oh, EBA. So what is this angle? So again, I'm going to get rid of some of my colours because it's confusing. I have too many. So we said this one was 35. I'm going to write that one. Right, so we want EBA. EBA, which is that angle down there. Now, BA is a chord drawn at the point of contact with the tangent. So that angle between the chord and the tangent is equal to any angle that you can draw in the alternate segment that is subtended from that chord. So if you look at this angle up here, then that angle 25 is subtended off that green chord, and the angle between the green chord and the tangent then is the same as that angle. So that means that EBA must be equal to 25 as well. So that is equal to 25 degrees. Question 20, simplify the root of 160 divided by the root of 2. Okay, so when we're simplifying surds, we're looking to break the surd down into factor pairs where one of the factors is a square number. So when I'm looking at 160, I'm seeing the factor 16, which is a square number, times 10. Okay, I've got 16 times 10, and I'm dividing that by the root of 2, and that's as simple as it's going to get at the moment. So what's that equal to? Well, I can break that off into 16, root of 16 times the root of 10 over the root of 2, and then root of 16 is just 4. So that gives me 4 root 10 over the root of 2. Okay, so what am I going to do with this now? Well, I can recombine those two surds I've got left as a single surd. I can say that's the same thing as 4 lots of the root of 10 over 2, because I can put them under 1 square root, and 2 divides into 10, leaving me with 5 and 1. So that's the same thing as 4 root 5 then, in its simplest form. Next up, we've got some laws of indices. 21a, work out the 1/8 to the power of 1/3. Well, fractional indices is the same thing as the cube root. So the cube root of 1 is just 1, and we need to work out then the cube root of 8. So what is the cube root of 8? It is 2. So that works out to be a half. And then we've got 2 to the power of x times 4 to the power of y is equal to 16. Show that y equals 2 minus x over 2. Okay. Now 2, 4 and 16, these are all powers of 2, aren't they? 2 is 2 to the power of 1, 4 is 2 squared, 16 is 2 to the power of 4. Okay, so I'm going to replace those powers with those numbers with their powers of 2. So I've got 2 to the power of x multiplied by 2 squared to the power of y, and that's equal to 2 to the power of 4. Okay? So when we've got an index of an index, we can just multiply those indices together. So that means 2 to the power of x times 2 to the power of 2y is equal to 2 to the power of 4. And then when we have numbers with the same base that we multiplied together, we add the indices together. So that means that 2 to the power of x plus 2 to the y must be equal to 2 to the power of 4. Okay? So now we've got 2 to this power is equal to 2 to this power. So because the bases are the same and I'm raising them both to a power and they're the same thing, the indices must also be the same. So that would imply that x plus 2y must be equal to 4. Getting close. So then taking the x the other side, I'm going to get 2y equals 4 minus x. And then dividing both sides by 2, I'm going to get y is equal to 4 minus x over 2 then, which I can then break away into two things. I can say that is equal to 4 divided by 2, which is 2, and x divided by 2, which is half of x, or x over 2 as it's styled in this question. So that gives me then that y equals 2 minus x over 2 as requested. Question 22, a sequence has nth term 2n squared plus 1. Prove algebraically that the sum of any two consecutive terms in this sequence is always a multiple of 4. Okay. So for two consecutive terms, I'm going to have the nth term and the n plus 1th term then, aren't I? Okay, they're going to be my two terms. So when n is n, I'm just going to get 2n squared plus 1. So the nth term is that. And then the nth plus 1th term is going to be 2 lots of n plus 1 all squared plus 1. Okay? Now I'm just going to multiply out what that is. So now when I'm multiplying out double brackets like this, or like a perfect square, I tend to use the identity a plus b all squared is a squared plus 2ab plus b squared. So I know quite quickly what n plus 1 all squared is. It's going to be the first term squared plus 2 times the first term times the second term plus the last term squared. Okay? Now if you struggle with that, you can just kind of do n plus 1 and use brackets, you know, FOIL or Greed method or whatever, but it's going to give you 2n squared plus 2n plus 1, and then I'm going to have that plus 1 on the end. Okay, and then removing the brackets, I'm going to get 2n squared plus 4n plus 2 plus 1 is 3, isn't it? Okay, so that's my nth term is 2n squared plus 1, and my n plus 1th term is 2n squared plus 4n plus 3. So what do we want to do? The sum of any two consecutive terms is a sequence is always a multiple of 4. So we have to add these two things together then, don't we? So the sum of two consecutive terms, that's going to be the nth term plus the n plus 1th term, which is going to be this thing plus this thing. So I'm going to get 2n squared plus 1 plus 2n squared plus 4n plus 3. Okay? So then collecting like terms, I've got 2n squared and 2n squared. That's going to give me 4n squared I've got a single term in n there. And then I've got a 1 and a 3, which adds up to 4. Okay, so that's how they kind of collect together. Now notice each one of these terms has got a 4 in it. So that means I can factorize the 4 out then, can't I? I can say then that's equal to 4 lots of n squared plus n plus 1. So that's it then, isn't it? It's a multiple of 4. It doesn't matter what n is. Whatever n is and whatever the result of working out n squared plus n plus 1 is, I'm going to then times it by 4. So if it's 4 times bigger than something, it means I can divide it by 4 again. So therefore, it's a multiple of 4. Always a multiple of 4. Okay, we did it. And with that, we've done the paper.
Mr. T, he's the best. Helps you ace every test. Maths worries now.